next lecture with Lake Johnson. As a friendly reminder, this lecture is being recorded. If you do not wish to appear on the recording, please keep your camera off. To reduce feedback, everyone was muted upon entrance. If you have questions during the presentation, please utilize the chat feature and I will read them out when appropriate. But please know there will be time for a Q&A at the end of the lecture. And with that, I'll pass it along, excuse me, to you, Gina Mills. Take it away.
All right. Hi, guys. I hope everyone is having a fabulous Monday. I'm going to go ahead and start sharing my screen so we can get this party started. Okay. All right. Is everyone able to see my PowerPoint? Okay. So again, thank you so much for being here with me tonight. I am Janina Millis, and I work for the Department of Environmental Quality within their Air Quality Division. And so tonight we're going to talk all about what it means to know the code, what that is, pollutants of concern, and so on and so forth. So just a little agenda for tonight. I know it kind of looks a little long, but these are just some of the things that we're going to chat about. Who I am, what DEQ/DAQ does, the hardest thing you will ever do, what is air, talk about some criteria pollutants, why do we care about this, how do we monitor, what is the air quality index, and more importantly, what we as individuals can do about our air pollution. So to kick things off, again, Janina Millis, work for the Department of Environmental Quality, and the department's mission is providing science-based environmental stewardship for the health and prosperity of all North Carolinians. So long story short, it is our job to make sure that the air we breathe, the water we drink, the soil that we use to grow crops and use to build on is all being used in an appropriate manner and still following all the rules and regulations that are being set in place by our federal government. So within the large overhead Department of Environmental Quality, there are lots of other mini sections or divisions. So our divisions consist of air quality, which would be me. I think we're the coolest, but I might be a bit biased. But we also have folks out on our coast who work with our estuaries and our oceans. We've got folks with the Energy, Mineral, and Land Resources who does all sorts of soil erosion stuff. We've got folks who solely focus on environmental education, which I think is why a lot of you all are here tonight. But we've got those who look just at fish, those who look just at our waste, those who are solely focused on our water. So all of us together are working towards this main mission of stewardship for all of us in North Carolina. So to break that down even further, Division of Air Quality, DAQ is the state division responsible for addressing the EPA rules and regulations and any requirements with respect to air pollution and air quality. So anything that the EPA says, we have to follow here at our state level. So just for some clarity, when I'm talking about air quality or ambient air, I'm talking about our outdoor air. So this is the air that we breathe when we're out at the playground or if we're out walking to work or getting exercise. That's our ambient air, that's our outdoor air, and that's what we work to protect. So to kind of get everybody in a air quality mindset, we're about to do the hardest thing someone has asked you to do today, and that is going to be, oh, I lied. I'm backing up for a second. So within the Division of Air Quality, I help run a nonprofit called NC Air Awareness. And this is a program really dedicated to education and outreach, mainly in our community with our education in respect to schools, but also partnerships as well, talking about asthma coalitions and driver's ed programs, so on and so forth. And our main goal here is to focus on voluntary actions to help solve air quality problems. So what are things that we can do on a personal level that will help make our air quality better? And so everything that we do, all the outreach that we provide, all the swaggy stuff we give away at tabling events, that's all free, which I think is really cool. So more information about NC Air Awareness. We have a Facebook and a website. We often put out internships and we do after school programs. We're often in radio interviews and newspapers, so you can find us all over the place. We also have some individuals within our triad region that they do the exact same thing that I do. They go out and provide free air quality education to all their different partners and educators, again, with the focus of what can we do on a personal level to make our air better. So now we're going to do something that's probably the hardest thing someone's asked you to do today. And because I almost gave it away earlier, that's going to be holding our breath. So I'm going to give you a little bit of prompting. So in just a second, when I raise my hand, we're going to start holding our breath. And we're going to keep holding our breath until I lower my hand. Is everyone able to see my hand? So when I lower my hand, we begin to breathe again. So as we're holding our breath, and I'm not going to tell you how long we're holding our breath for, I want you to take observation of how you're feeling. What is your body experiencing? So because we're about to do this super difficult thing, we need to prepare our bodies a little bit. So if you're sitting, sit up nice and straight. If you're standing, stand up nice and tall. And we're going to take some deep breaths in together. So we're going to inhale and exhale, inhale and exhale. And I'm getting ready to hold my hand up in 3, 2, 1. Okay, whew. Let all that air out and get all that oxygen back in your body. And if you would like, go ahead and throw into the chat, or if you would like, unmute yourself and tell me some of the things that you were feeling. Or if you would like, tell me how long you thought we held our breath for. All right, I'm not able to see the chat, so I don't know if any responses are coming in.
Yeah, people are saying 20, let's see, people think it was held for 20 seconds. Made them feel anxious. Some said they couldn't hold it that long. Lots of people said they felt anxious or their chest felt tight. Heather says she realized she needs to work on better breathing techniques. Someone said they felt nasal pressure, but generally the overwhelming agreement, consensus, that's the word I'm looking for, is that we felt anxious trying to hold our breath for that long.
Okay, fantastic. Those are very, very good answers. So yeah, I'm not glad you felt anxious, but that's a very normal thing to be feeling for 2 main reasons. One, I told you were about to do the hardest thing someone's asked you to do today, and I didn't tell you how long you were going to do it for. Well, second part is no, I didn't tell you how long you were going to do it for. So your brain went into stress mode. It said, okay, what do I need to do to keep ourselves alive? What does this look like? So for those of you who said there was tightness in your chest, totally normal. I know for me, I sometimes get really hot all of a sudden. Sometimes you may feel like your head get really lightheaded, you may feel a little dizzy. And yeah, so very good. To talk about the pressure in our chest. So when we take in oxygen, our body converts it to carbon dioxide. And so even though we aren't breathing, our lungs are still converting that oxygen to carbon dioxide. So when you feel that buildup of pressure in your chest, that's a buildup of carbon. So because our body wants to expel it, that's why you feel the need to breathe. So again, all total normal things to be feeling when your body's under stress, but more importantly, these are things we feel when we're not getting the air that we need. I think I heard someone say or mention that we held our breath for about 20 seconds. Close. We actually held our breath for 30 seconds. So if these are things that we're feeling with just 30 seconds without our air, the air that we do breathe is really, really important. And it's really important that we do what we can to keep that air clean, because we don't get to make the choice of, oh, I'm only breathing clean air today, or I'm only breathing dirty air today. So with that being said, oops, sorry, friends. Okay, thinking about children and adults, who do you think is going to breathe the most in about a minute?
All right, looks like most people are saying children. Yep, children, kids. Seems to be the consensus that children breathe the most.
Yes. All right. Fantastic. You guys all get gold stars. Yeah. So, children, people with developing bodies, growing lungs, they're going to breathe the most for two main reasons. One, we all know children have a lot of energy. And because they're constantly using all of that energy, they have to get it back somehow. And they get it back through all the nutrients that we get from our air. Also, because they're still growing. So, for an adult, we take about 20,000 breaths a day. Children, they're going to take about 30,000, so not quite double, but still more than what a fully developed adult would breathe in. So we're going to look at that. Children are breathing about 16 to 25 times in a minute, adults about 10 to 20. So again, smaller lungs, not enough surface area, and have to take in more breaths to get the same amount of nutrients that we would have to take. And so if you're a numbers person and you want that broken down a little more, here are some extra numbers for you. But the main numbers are about 10 to 20 per minute for an adult, and about 16 to 25 for growing bodies. And so for those of us who are a bit more visual, if we're going to talk about the air that we breathe in one breath and put it somewhere, that air would go into about a 24-ounce bottle of water. If we're talking about the air that we breathe in a day, that's roughly 3,000 gallons, which is about the size of that big old tank on the back of that pickup truck. So a very sizable amount of air that we're taking into our bodies. So that being said, air. When you hear the word air, what do you think of? And if so, go ahead and throw that into the chat, or feel free to unmute yourself. So air, what do you think of it? And what makes up clean air?
All right. So, a lot of people get a couple folks say elements of air like oxygen and nitrogen. Um, Raylene said, I need clean air, but I do not know how to clean it.
Okay.
We got some saying when we think of air, we think of relief and how it feels good to take a deep breath. Air is vital to survival. Clean air does not make you ill. Clean air means no pollution or air without a lot of air without a lot of particulate matter.
Mm. Yeah, those are all fantastic responses. Thank you for throwing those in and shouting them out. So yeah, a lot of those things are what I think about when I think of air too. I also think wind. I also think invisible, but I can still feel it and I can see the effects of it. So air, wind blowing through a tree or through someone's hair. But yeah, like you also said, I also think about the elements of air. So what does it mean to make air? What is clean air? And so here we have a chart of all the different molecules, all the different ingredients that make up our clean air. So in first place, we have nitrogen, with about 78% of our air being made of nitrogen. In second place is oxygen at about 21%. And then everything else below that are really, really small percentages. So argon, carbon dioxide, neon, helium, methane, krypton, and there's even some water vapor in our air, aka humidity. So with that being said, if we had zero water vapor in our air, we would be living in the desert. You know, that air is dry, no water in there. That 4%, we're looking more about what it would be like to live in the rainforest. So North Carolina, our water vapor percentage is about 2.5%. So not bare bones dry, but not drowning in water. So one other thing that I really wanted to point out is when people think about air, they probably think about carbon dioxide. And when they think about carbon dioxide, they think, oh, that's a pollutant. We need to get rid of it. But because it's an ingredient, we do still need that 0.04% to make up our air because of that exchange of gas that we have with plants. So again, air has ingredients. So basically what that means is if there's too much of something, things can go wrong. If there's not enough of something, things can go wrong. So like when we're baking, if we've made brownies or cupcakes or other sweets before, we know that if we add 1 egg too many, that brownie's going to come out looking a little weird. But we know if we don't add enough flour, things are also going to look kind of funny too. The same with our air. We need all those same ingredients, but it's when we add too much of something like carbon dioxide, things in our air and our atmosphere start to get a little funny. So let's talk about some of those things that can make our air a little funny, make those pollutants. So here in front of us, we have 6 criteria pollutants. And basically what this means is there are 6 common pollutants. And this is something that the EPA came up with a long time ago. And they kind of surveyed the United States and said, okay, well, we see a lot of these things here. So these are the pollutants that we really need to keep an eye on. So we have ground level ozone, which is a secondary pollutant. It's not directly emitted from anything, but it's a combination of VOx or volatile organic compounds and NOx, nitrogen oxides, which we have a graphic for that here in just a second. So I won't dig too much into that. But we also have particle pollution, so really teeny tiny particles and liquid droplets that can end up in our lungs and in our system. But we also have nitrogen oxides, which are reactive and can make new substances, which are part of that ozone. We also have sulfur dioxides, which is when sulfur is burned. We've got lead, which can be found naturally or is man-made. But I will say with lead, there's been a large decrease in pollutants because of lead phase out in gas, but can be found in high concentrations near lead smelters. And then we also have carbon monoxide, which is a large source of on and off-road vehicles. So those are the 6 common pollutants that the EPA has set aside for us. But the ones that North Carolina is most concerned about is that particle pollution or particle matter, but also ground level ozone. So we're going to start with the to scale drawing on the side here. And that gray line kind of going through the middle of that picture is a single strand of human hair. So if you've got hair long enough, or if your hair is down, go ahead and just take a strand of hair and run it through your fingers. That's really thin. It's about 50 to 70 microns in diameter, so really itty bitty, teeny tiny small. When we're talking about particle pollution, or PM, we're talking about particles that are 10 times and 2.5 times smaller than the width of our hair. So if we're looking at our blue dots here, that is PM10, and that comes from dust, pollen, mold, which can be 10 microns in diameter or bigger. And then we get even smaller to PM2.5, which are those little pink dots that are fitting inside of the blue dot. And these can come from combustion particles, organic compounds, metals, or anything that's 2.5 microns in diameter or smaller. So I want to just talk real quick about combustion particles. So combustion is to light something on fire. So these combustion particles can come from lighting a candle, setting off fireworks, having a bonfire, wildfires, or even the exhaust or the burning of gas from our vehicles. So combustion can come from a lot of different places. And so why we're really concerned about PM in our state is because these particles are so small that sometimes they pass through the natural barriers in our body. So like the nose hairs that we have, and even surpass some of the other barriers in our lungs, and can actually get into our blood and travel throughout the rest of our body, causing other issues, especially to our respiratory system and our cardiovascular system. So really important to limit the amount of PM that we create when we can. So the other half of these pollutants of concern is called ground level ozone. So I would argue that everyone here has heard of ozone. And when we talk about this ozone, we're talking about in the upper layers of our atmosphere, and that's good. We want it there because it protects us from the sun's harmful UV rays. But the ozone that we're concerned about is created down here on surface level with us. And one thing I find really interesting about ground level ozone is it's not a byproduct of something. It actually has to be made or baked. And so again, going back to those ingredients, there are four main things that are needed to create ground level ozone. So the first is sunlight. The second is heat. It's not listed, but it's very, very important. Then we have nitrogen oxides, which again is that kind of chemical that comes out of the back of our car when we turn it on. But we also have VOCs, or volatile organic compounds. And this is just a fancy word for anything that smells. So that could be the banana we had for breakfast this morning, or the deodorant we're wearing, or it could even be the pine trees that we have naturally growing all over the state. So with these four things baked together, that creates ground level ozone. And this becomes a problem for us because with short-term exposure or even long-term exposure, that ground level ozone almost acts like hydrogen peroxide in our lungs. So you know that bubbly stuff we poured over our scrapes when we were younger, or maybe still today, given what we do. Yeah, ground level ozone acts like hydrogen peroxide in our lungs, which can be an irritant and can even cause some longer-term issues and make existing respiratory problems worse. So, knowing what we know about ground level ozone, pop quiz. What season do we need to be most vigilant about ground level ozone? So do we think it's spring, summer, fall, or winter? All of them or none of them?
See, we've got one vote for summer so far and one vote for spring. Other answers are coming in. I'm going to vote summer, personally. So 2 votes for summer.
Okay, well, the summer votes
That's
have it. Yeah, the summer votes have it. So the reason this is because summer is the time of year when we get the most sunlight and the most heat, those two very important ingredients that we need to make up ground level ozone. So with that, there are folks in our office that monitor for ground level ozone, and we have a ground level ozone season. And that season starts March 1st, so we're at the very beginning of that season, and that goes until October 31st. And so we have kind of a ramping up of lots of hot, sunny days to a peak, and then we have kind of that fall off. So just like with our seasons, there are certain times during the day where we need to be most aware of ground level ozone. And that's going to be around noontime till about 4 o'clock. Because again, as that day goes on, you have all these ingredients present that can bake and form under the sunlight. Gets really high and really hot during the middle of the day, and then it starts to fall off in the evenings. So everything you need to know about PM and ground level ozone. So where does some of this air pollution come from, or some of these ingredients to air pollution come from?
Answers are coming in slowly but surely. All right, so far we've said cows, automobiles, burning trash, disaster activities, lawn mowers, industry. A couple more. We got the three dots going, so should have another couple answers. Restaurants. Think that is it. A couple more votes for automobiles.
Okay, cool. Yeah, no, those are all fantastic answers. So when we talk about the different sources of pollution, we're really looking at kind of four buckets. The first being point sources. And when I talk to my students, I say these are the things you can actually point to and say there's pollution coming from that. So these are going to be our power plants, refineries, industries, things of that nature. And the second is our area sources. So these are things that are generally happening in an area. We may not be able to physically point to them, but we know that they're happening. So we know people are running their dry cleaners and houses are being renovated and solvents are being used. But then we also have our on-road sources. So yes, very much so along the lines of our cars and trucks and buses, anything that gets us from point A to point B while we're on the road. But then we also have our off-road mobile sources. So again, these are things that move from point A to point B, but we don't necessarily find on our road. So planes, trains, construction equipment, and pretty much anything that requires gas to make it do its job. So that being said, cars and trucks are the leading cause of ozone pollution in North Carolina. So we're looking at NOx sources, so things that give off that nitrogen oxide. And our on-road sources, which is that gray part of the pie, makes up 78%, or sorry, 48%. So almost half. So a very big portion of where our pollution comes from is in fact our cars and trucks. So keep that in the back of your mind the next time you decide to go through Starbucks and wait forever in that drive-through line. You can always make the decision to park and go inside and pick up your order. It'll save you some money and gas, and you'll probably get your drink a little bit quicker too. So even though we have all this going on, and these are things we do need to be vigilant about, I feel like it's very important to let everyone know that North Carolinians are breathing the cleanest air in decades. And so we kind of capture all that information in what is called the Air Quality Trends Report. We had one that came out in 2023, I believe is the date on that. But main takeaway here is from 1990 to 2020, all these emissions for sulfur dioxide, carbon dioxide, nitrogen oxides, particle pollution, and our VOCs, or volatile organic compounds. Those emissions significantly fell between the years of 1990 and 2020. So again, thanks to state leaders and regulatory agencies, individuals kind of taking action, we were able to make these things these emissions fall. And if anyone is interested in looking at the trends report, I would be happy to drop the link for that into the chat once we're done. So just remind me and I'll get that to you. So again, for some of those of us who are more numbers based, just a couple of charts looking at kind of how that progression or that fall off has looked over the past several decades. So 98, we were really high up there with our nitrogen oxides and our SO2. And then by 2022, we were way below the nitrogen oxide cap, which came out in 2009, and the SO2 cap in 2013. So we are making progress in breathing clean air. So again, why do we care about this? Because of human environmental impacts. So air pollution, or specifically asthma and respiratory problems, are a major reason why students miss school and why adults miss work. And air pollution doesn't just affect us, it also affects other animals that have respiratory systems. So all the same symptoms that we have, those animals can have with respiratory systems. But the environmental impacts on our plants is pretty significant too, specifically our crops, for example, because of how it messes with their reproductive systems and their growth cycles. So if you're expecting an entire field of corn to be produced, you're probably going to expect a lower crop yield, but also a smaller crop size, and therefore not going to have enough nutrients in that piece of corn for this example. And we'll have to grow more to get the same nutrient value for what a single ear of corn would have been. And it also really impacts our economy. So this here are two separate pictures taken from the same place in Asheville on a poor air quality day and a really good air quality day. And so when you're going to the mountains and you're expecting to see beautiful, beautiful views for miles and miles and miles, but you go on a day where you can't see anything, the likelihood of you actually staying in that area to spend your dollar at the bookstore or the local restaurant is going to be a bit lower than if you had, a reason to stay there, which was for those beautiful views. So air pollution does impact our economy, specifically because of the degraded visibility, which leads to a loss of tourism revenue. So big picture here, air quality really does play a big part in all these different aspects of our lives. So how do we know what's in our air? So these pictures were taken from, they were taken in Winston-Salem. One is a good air quality day and the other is a bad air quality day. So not all the time can we see the pollutants in our air, but our body can actually tell us, something's going on. And we usually feel that in the way of coughing, wheezing, maybe our eyes burning a little bit, maybe if that's particle pollution. So our bodies can let us know that something is wrong. But one surefire way to know is by looking at our ambient monitors. So within the state, we have a wide range of ambient monitors kind of placed throughout our entire state. We've got local air quality programs, which are in Buncombe, Forsyth, and Mecklenburg, but we also have forecasting programs. So the Division of Air Quality, we forecast for 91 counties, where Forsyth, they do their 9 counties. So by using these monitoring systems, we're able to tell folks like you all what the air quality forecast is going to be and kind of what actions you can take to be safe during these times. But before I get into that part, a little bit more about the air quality monitoring. So these stations kind of look like brick houses in a way, fenced in. And what these little brick houses do is they house a lot of air quality equipment. I believe this site specifically is in the Winston-Salem area. But inside these little houses are a bunch of monitors and tubes and like a big funnel at the top, which captures the air in that area and then kind of divides it out to whatever that specific monitor or that specific machine is looking to read. So there might be a pipe for carbon dioxide, there might be a pipe for ground level ozone for SO2, so on and so forth. Some monitors monitor for all 6 of those criteria pollutants. Some of them only monitor for 1. And that is just kind of dependent on whatever the permits were at the time that these stations were erected. So we get all this information from air quality monitors, but where does it go? So the monitors that are monitored by the Division of Air Quality, all that information is put into the Ambient Information Reporter, which I can also drop the link to in just a few minutes. And so one thing I want to let you know about the Ambient Information Reporter is that some of these areas where there's a box with a number in it, these are our air quality monitoring stations that the Division of Air Quality actually uses. All these other numbers are ambient air temperature, so what the temperature is outside. So just something to be aware of when you go onto the website and want to start poking around. And so off to the side, you can also kind of toggle over that and show what the conditions are going to be for different periods throughout the day. And when we're on the live website, this area here will let you kind of toggle through those different pollutants. So ozone, PM, PM 2.5, PM 10, and that can show you more specifically what the concentrations are within those air quality monitoring stations. So our forecasts are done by our meteorologists. So we have 3 in our Raleigh office, and then Forsyth also has a handful of meteorologists as well. So again, they're the ones that collect all that information from the monitoring stations, do their meteorology thing, and send that information out to us, being the public, so we know what to do for our day. So, real quick in the chat, if you were trying to predict the weather, what are some things that you may think of? So, for example, the first thing I think of is wind speed. So, what are some other things you might think of?
All right, so far we've got heat, cloud formations, rain, temperature, precipitation more broadly, barometric pressure, humidity, uh, closeness to proximity to the ocean or to large bodies of water, barometric pressure, different systems coming through of high pressure versus low pressure, dew point. I think that's it.
Okay, cool. Yeah, those are all fantastic answers. So, because of these are things that we think of as a casual weather observer. So again, temperature, precipitation, wind, solar radiation. These are all the things that an air quality forecaster has to consider before they put out that forecast for the day. I am not a meteorologist, so a lot of these things I have no idea what they mean. So I really appreciate the meteorologists that we do have on staff. So it's just this one big puzzle that they're having to work on, 365 days a year to put out that air quality forecast for us. So if you have an interest in being a meteorologist, kudos to you. So now to the code. After our meteorologists take all those funky things into consideration, they come up with the AQI, or the Air Quality Index. And what that number does is it falls within one of these categories, and it lets us know what the air conditions are. So if I were to say today's air quality index was 45, well, that 45 would fall in that green area, which means the air quality is good. We can go about our day as normal. There aren't any modifications we need to make. And so as that number increases, it will continue to fall into one of these different colored categories. And they all mean something different. So once we get to that orange level between 101 and 150, that means it's going to be unhealthy for sensitive groups. And our sensitive groups are going to be our young people, our older people, active folks, and those who have pre-existing respiratory conditions. When we're in that orange conditions, these people tend to feel the effects of that air pollution a lot sooner than most everybody else. It's when we get to the red, purple, and maroon areas where we will tell people, it's not a good idea to go outside at all, limit your exposure, do what you can to stay safe. So last year, our PM 2.5 standard was changed. This was through the EPA, and these are the different breakpoints, so kind of where these different categories start and stop. So previously, we were looking at 0 to 12. Oh my goodness, I forgot the number. But 0 to 12, whereas now the requirement is a lot stricter from 0 to 9. So the EPA updated the breakpoint between the good and the moderate, so the green and the yellow, to reflect the updated annual standard of 9 microns per cubic meter. So we went from 12 to 9. So that being said, this year you might see more yellow air quality days than what we have in the past. And that doesn't mean our air quality is bad or is getting worse. It just means that we have more stricter guidelines to follow. And this is all to continue that air quality improvement. And ground level ozone has very similar breakpoints, looking over an 8-hour average. So how do you protect yourself? How do you know the code? So the first one we talked about was the Ambient Information Reporter. And again, I will be happy to throw that into the chat in just a few moments. But the other is the EPA airnow.gov, and we can go to that in just a second. Because what I really like about this specific website, which is also an app, is it allows you to kind of bookmark different places throughout the country. So if you have people in California, you can kind of be that informer for them and let them know what the air pollution is going to be like for the day and help them protect themselves. But you can also check places that you might be traveling to just to kind of get an idea of what activities you're going to do when you get there. So like I said, we'll go to those websites in just a moment. So we get a lot of these, or people can get these data from different places, from our being NCDAQ discussion and forecast, from some data sets. People also have personal air quality monitors like Purple Air. AirNow is also one. And these are all very good for a lot of different reasons, but they are very different for a lot of different and good reasons. And because I am running out of time a little bit, I'm not going to go through all of these with you. However, if this is something you're interested in learning the differences and how these numbers are produced and what the measurements are and kind of what they do individually, our meteorologist did come up with a blog post, which I can post in the chat, which goes into detail about how each of these things are different and what they can be used for. So that being said, what can you do to reduce air pollution? So we know what's air pollution, we know where it comes from, we know how to check to make sure that we're safe and can share that information with other people, but what can we do personally? Kind of the first biggest and easiest one is just use less electricity. Using energy efficient appliances, turning lights off when you're not in a room, turning off appliances when we're not using them, gaming systems, televisions, computers, but also unplugging things when we're not using them, if it's easy to get to, but driving less and commuting smarter. So EPA has this really, or not EPA, but Fuel Economy has this really interesting website where you can go in and plug in 4 different vehicles, and it can tell you what their greenhouse gas emissions are, what the EPA smog rating is, but also miles per gallon and how much money you would spend or save over the course of 5 years in fuel. So just a fun little website to visit if that's something you're interested in. Again, to help you make decisions on driving smarter. But avoiding idling, deciding to park instead of wait outside of Starbucks for so long. Keeping your car well maintained is really important. Tire inflation, wheel alignment. Driving sensibly, driving smart. So avoiding speeding and tailgating, practicing smooth acceleration and braking, coasting whenever you can, using cruise control, but also planning and combining trips, and avoid driving during peak times. And just as a reminder that it's really important to avoid burning vegetation or brush, and it's never okay to burn trash. So by doing these small practices, we can help continue to make North Carolina air the very best it can be. So I don't know if we share out PowerPoints or not, but if we do, I'm happy to do so, and you all will have access to these different websites. The DAQ website, AirNow, which we'll look at in just a second, and some other programs that NC Air Awareness provides, like Like It or Not, which is really fun and I think you should look at, but also some idle reduction practices that you can partake in.
After the lecture, if you just want to send me the PowerPoint, I'll be sending a follow-up email, hopefully by the end of the week, with the EE form and the recording of this video, and I can attach the PowerPoint as well if you want to send it to me.
Okay, yeah, fantastic. All right, so I'm going to move real quick to the Air Now website just so everyone can kind of see what that is about, because I think it's really helpful. And it's really nice because it is an app as well. So earlier I went ahead and I plugged in a zip code, which happened to be Newport, North Carolina. And so this kind of barometer showed up and told me what the air quality was for that zip code. So right now, the air quality is good, so it's green. But one thing I think is really cool is it tells you what the current air quality is for both ozone and PM 2.5. So we're both green in the good for both of those. But then it will also tell you what the forecast is. So what the prediction is for today, tomorrow, Wednesday, Thursday, so on and so forth. And so we'll click on tomorrow since today is almost over. And the forecast for ozone is going to be that 35 good. And the forecast for PM 2.5 is going to be 35 good. So these things would show up regardless of what zip code you plug in. And we'll be able to have those breakdowns even further. To pop over to the ambient information reporter. So again, here we have the state of North Carolina. Each of these little boxes with the numbers in it is an air quality monitoring station. So this one specifically is in New Hanover, and it tells you what, so the O3 is ground level ozone, PM 2.5 and PM 10 will be. And then there's also an option to click further into the specific site for more data. And then we also have stations that tell you what the ambient air temperature is going to be, along with some other meteorological data as well. And so over here where I just hovered over, we're currently looking at ozone Yes, we're looking at ozone concentrations, but we'll also be able to see PM 2.5. So we've got changes. And again, some of those monitors show PM 2.5 and some of them don't. But we can also look at NOx, which is our nitrogen oxides. Again, some of those stations pop up. And so anyways, this is just a really good site for you to go in and play around and kind of get an idea of what the larger air quality picture is for our state. And with that, I will open the floor to some questions. And I'm going to go ahead and stop sharing so I can see everyone.
Wonderful. Thank you so much. That was a really great talk, super informative, really great resources shared as well. Thank you. And I totally mispronounced it earlier. How do you actually pronounce your name?
So it's pronounced Janina. You were really close.
Janina.
Yes.
Great. All right. So I know I saw one earlier. First of all, Raylene, did we answer your question about measuring different gases? Do you feel good on that? Okay. Yeah, so she was curious about how you measure the different gases. And then, yeah, how do you measure the different gases? And then Shauna asked, what is EGU?
Oh, okay. I'm going to answer the EGU question first. So thinking about that pie chart, that EGU means energy generating units. So what are the things that we use to get our energy? So that could be burning coal, burning nitrogen, or not nitrogen, burning natural gas, burning nuclear. So the things that we have to burn to get our energy, those are the things that are going to put off particles or other gases. Yeah, great question. And what was the question about the measuring?
Yeah, she was curious how you measure the different gases. Raylene, can you clarify your question, please? I don't know if she heard me.
Okay. Um, so I personally
I
am not sure
I'm
how.
not.
Oh,
Sorry,
hi.
I'm a slow typer. I'm sorry.
No,
I
you're
was just
fine.
curious. I was just curious to know, how do you know, like, how much you were talking about all these different types of gases in our air to, like, keep us clean or get us dirty or whatever. Like, how do you know how much nitrogen is out there that we're actually breathing in, or these particles? How do you know? How do you measure that stuff?
So I think a lot of it comes down to our air quality monitoring stations. You know, these things are so fine and there are so many of them that it's not something we can just do on our own. It's going to take a lot of technology and um, a lot of information from a lot of different places to kind of come up with those numbers. I'm sure I'm not answering in the best way possible, but it's really down to our monitoring systems that do a lot of that work for us and through the equipment that's in those stations.
Great. A couple more questions in the chat here. Betty Jo says that her students are doing an air quality project. Do you ever allow students to share their findings with your office? They're using Pocket Lab Air for collection.
Ooh, so so as a matter of fact, the Division of Air Quality hosts an AQIQ project every year. And this is just for seventh grade students, unfortunately, but because of how the standards are aligned, that's why it's open to only seventh grade students. And that project deadline was actually today. So
Oh,
that's one way students can get involved with air quality. But if your students are working with, what did you say, Pocket Lab Air, and they want to share, please send me an email. I would love to look it over or maybe we could work something out and I could come into class and kind of see what you guys are doing. Um, I'm always looking for options or for opportunities to come to classes and speak to students.
great. Another person asked, are there methods or technologies that North Carolina is using to help clean the air?
So the first thing that kind of comes to mind is in these big smokestacks that a lot of these refineries and industries use, they have what's called a scrubber, and it's basically a giant filter inside that smokestack, and it's capturing the pollutants before they even come out. Now that's more of a preventative measure than a cleaning the air, so to speak, because there is no way to clean the air. It's all preventative work. So that's why we really talk about focusing on voluntary actions, things that we can do that prevent the air from being dirty in the first place. Because there's not some magic wand we can wave and all that air pollution is going to go away. Great question.
Great. Yeah. Last call for any other questions. No, you were talking about how air quality, how poor air quality affects the economy and
Mhm.
affects tourism, things like that. I was also thinking about how, as someone who works at park, it affects our outdoor activities. Like we wind and it affects camps. So
Yeah.
programs wind up getting canceled. People want to go out kayaking or out hiking, or kids want to be outside playing field games, exploring outdoors. But then when the air quality goes up like that, you can't. So things get canceled, and that's money that's not going into the economy anymore.
Right. And not only that, but like it also kind of hurts your feelings too, because these kids are there and they're excited and they want to be involved in outdoor things, but it's like, oh, we can't today. There's too much, ozone out there for us. And I've been in this position for a couple years now. And was in this position when we were affected by the Canadian wildfires. And I will go into classrooms today and we'll talk to second graders and they will say, oh yeah, remember when we weren't allowed to go outside and play for those couple of days over the summer? And it's like, whoa, I didn't realize how much you actually, paid attention to that. But they really, what is happening in our air and in our world really does affect our students.
Yeah. All right. If there are no further questions, then we are going to start wrapping up for the night. Thanks again for joining us, everybody. Thank you, Janina, for presenting. Again, if you are seeking EE credit, you are going to get a follow-up email later this week, hopefully, with the form as well as the recording, a link to the recording on YouTube, and hopefully Janina's presentation. Are you also okay with me sharing your email out to participants if they want to reach out to you with questions or for student work?
Yes, please do. I'm constantly checking my email and love answering questions because 9 times out of 10, I also learn something too. So
Wonderful. In addition, I hope that you will all join us for our next lecture in April. It's going to be the second Monday of April. And we are going to have Margot Lester from the Word Factory. She'll be speaking about climate storytelling. So hope to see you guys then. Email me if you need anything else. All right, everyone, have a good night.
night all.
Raylene, to sign up for the April class, you just go on RecLink, same way that you signed up for this class. You're welcome. Thanks, y'all.